Okay, grab the packet.
Take his phone?
Huh?
Take his phone?
No, he's farting in the hallway. Because I taught him how to leave the room instead of blue light. Your packet out, Paul.
All right. And if you haven't noticed yet, I'm super excited about my desk. So I actually had this desk at home, and I hadn't really used it since college. So I was like, I would really like to have this at school. I need more room to work. My old desk, probably from the 70s. It really wasn't that big once I had everything on there. And like the drawer in the middle, you had to have out a certain distance in order for the other drawers to work. It was like this whole like equation that, it was complicated. So I'm really excited about it. I just need to share it because I'm just so excited. All right. So up until today, what kind of triangles have we been studying?
Right.
Are all triangles right? So, the first thing we're going to study is the law of sines, and it allows you to set up proportions with the angles and the side lengths. So you'll use two of these at a time. So for example, you would use those two together, or those two, or these two, right? Depending on what you're given. Okay? So let's try one. So I'll do my best to draw this first one out. We have angle B is 100 degrees. And then we have C. Call that A. C is 50. And then where do I place little c?
On the opposite. In between B and A.
Yeah, across from angle C, right? So 30 goes here. And if it says to solve for the triangle, that means find all missing parts. So there's one thing that's the easiest to solve for. Okay, what's angle A?
30.
30. All right, so setting up what we're given. See how we're given big B, big C, little c? I'm going to go ahead and solve for little b. Okay? So you would set up sine of 100 over little b, and then sine of 50 over little c, which is 30. Now, everybody make sure you have a calculator. I have 10 yellow ones now, which actually is something I started with this year. But some went missing. I don't know anything, but I don't know. What mode should we be on?
Degree.
And how do we solve an equation that's set up like this? Cross multiply. Okay, so we have b sine of 50 equals 30 sine of 100. And then we would divide by sine 50. So 30 sine of 100 divided by sine 50. So I'm getting 38.567. So far?
Yeah.
All right, and then do the same thing for A. So you're going to have sine of 30 over little a equals sine of 50 over 30 again. I've gone verifications already on that. My best friend, so we're using. All right, 19.581 sound right?
Yeah.
Cool. All right, next. All right, one more is the same. The only thing I changed up. What's that? 15.
It's minutes. Sorry.
How many minutes in a degree?
One
Oh, it's a shoot.
one.
So,
Degree.
60 minutes in 1 degree. All right, so it's 15 over 60. Yeah, 1/4 is 0.25. So A becomes 39.25 degrees. Okay, go ahead and convert C, and then set up your law of sines and finish up.
That's uncomfortable.
She said convert C.
Oh.
Yeah, I said that.
Convert C.
Converting
Okay, and then for oh, now I see right there, we're on A, yeah. And that gives 39.5 degrees, write it down.
Now do the same thing with the.
Oh, okay, that's easy. For 1 times 1 degree over 16 minutes. Now that we will, this is easy. So now 0.75 degrees. Global warming. I know. I know that. I just got there. Yes.
All right, what did we get for little a? Consensus 13.501?
Yeah.
All right, and then let's see, what's angle B?
76.
76. Good, good. And then let's set up that.
My kids are what's going on.
All right, and then little b.
So when
It's an insignificant digit.
All right, are there any questions on getting those numbers?
A, B, B, A, C.
I'm gonna go on and we can come back later, okay?
No, can I just punch in the answers? Because I can figure like the rest out because they list the formula. So you can just plug everything in.
We're talking right.
Dang it. Sorry, I'm B is 20.705.
Online anyway.
Done.
Okay. So, yeah, these next two slides, ready? They look a little intimidating, right? Those two charts.
pretty much.
Okay, but don't worry. You will get the charts on the test, okay? So we're not memorizing these charts.
I know, but she might.
Do not memorize.
Okay, got it? Okay, what does this mean? Ambiguous. It means
You don't know.
I don't know what
Right.
it means.
Unclear.
Oh, yeah, unclear.
Unclear.
Up for interpretation maybe until you narrow it to something else. So in our cases, we'll be able to narrow it down to either it's possible to make a triangle or it's not, and how many.
Sorry.
So what happens when you're given certain measurements? So if you're given, in this case, you're given a side, two sides, and then an angle. And the visuals help out. So you can kind of see, like if this angle is set, angle A is set in stone, but little a is that short, is that ever going to be able to form a triangle?
No.
Right? You'd have to change angle A, but you can't change angle A because it's given he's set at some degree of measure. You know what I mean? Okay, so like maybe you'd have no solution here. Side A is perfectly lined up so that you can have a triangle. This is the most interesting case, where there's two possible triangles. So what happens is, again, this, and this are set. They're fixed. But this A could swing here and make a triangle, or it could swing there and make a triangle. So you actually have two. Okay? Now look at this. So, and we're going to do one here in a minute, but let me try to describe this to you. So, so you'd have, let me draw it. You'd have this blue triangle here, see? Or you have that red triangle. And here's what's cool too. That angle, that green angle, is that obtuse or acute? Okay. What do you know about this angle?
It's a cube.
Right.
It's a cube.
Right.
Which angle?
It's not isosceles triangle.
Why?
Right.
Because those,
I thought you were talking about the 90.
Oh, no, I'm sorry. This one over here.
Yeah.
So Aiden says, because this is A and this is A, these are the same angle, right? Okay. So then, how could you find, or no, colors is gonna be purple. How could, if you found one of those green angles, or the green angle, how could you find the purple?
Track 180.
Okay, and isn't that purple angle?
Complementary.
Oh, sorry, supplementary, yeah. Yeah. So, if you can remember, complements are always right.
Oh, yeah. That's a good one.
And you said the word, Brian. You said obtuse. Are you guys with me?
Yeah.
We're gonna come back to this in a little bit. One of your versions of the angle you get is acute, and the other one is obtuse. And you can find each other by subtracting from 180 because they're supplementary. Okay? All right, and then as far as using this chart, everything's given in terms of A and B. So we may have to adjust our letters to be able to read this. So you have case 1 is when A is less than 90. Case 2 is when A is greater than or equal to 90. Let's try them. Determine the number of possible solutions. So, first I'm going to note, are my letters matching up with the chart? Well, I have A and then I have a C. So let's just relabel because we're allowed to do that. A and A are good, but instead of C, what do I want to call that? Now we're good to use our chart. So your chart, you first decide, is the angle that I have bigger than 90 or less than 90?
Less than that.
So I'm in this scenario. Okay? Then to narrow it, you decide, is my A value less than B or greater than B?
Less than.
A is less than B, right? Good so far? So now we know we're one of these three. These three all depend on this B sign of A, don't they? Whether it's A is less than, equal to, or greater than. So we need to compute B sign of A. So B is 26, sine of 30. Now before you use your calculator, isn't 30?
Is that 26 or 2 B's?
Oh, yeah.
26
I thought so.
Is 30 one of our special things? Yeah.
Yes, it is.
Okay, can you visualize it and tell me without your calculator what sign is 30?
13. 13.
Well, before we get there, 1/2, right?
Oh, yeah.
Opposite leg is 1, hypotenuse is 2. So then if you multiply half by 26, you get 13. Oh, sorry. I confused on the wrong side.
Dang it.
I'm sorry.
Okay. So what, in relation to A, 13 is what?
No, equal to 1.
Equal, isn't it? So you see how this works?
Yeah.
So since A equals that number, we have one solution.
There.
Okay. Number 2, we need to relabel as well, right?
Yeah.
So angle B, what does angle B need to become?
A.
Which makes little b
Little a.
and little a.
Little b. Little b.
Little b.
Yeah.
Sounds like a rapper.
Yeah, it does.
Why did we do that?
We do that just so, because all of our chart is given in A's and B's.
Okay.
And we want our A, big A to represent the angle. So it's just easier. Okay, so if big A is 37. Are we in case 1 or 2?
Case 1.
1 again. This is the more interesting thing. Is A less than B or greater than?
A is greater than. No, less than. It's less than.
Yeah, because everywhere.
It's less than.
Yep. So again, we need to compute B sine of A. Now this time, 37 is not friendly, so you need to calculate.
Whatever, it doesn't matter.
And just give me nearest whole number, what is it?
1980.
You better just like that man.
Okay, is A less than, greater than, or equal to?
Whenever one, two.
So how many triangles? 2.
You know, the most I'll ever learn here is from that math rap battle.
Really? That's the most you'll ever learn from people?
That won't be your wall, it'll be mine. No, I'm kidding.
Alright. Let's do the 2 solution case, alright? So I told you, I'm giving you here, we're surpassing how to use the chart, and I said there are 2 solutions, okay? Let's find both of them, okay? So what are we forced to solve for first? Based on what's given.
We spoke to these. No. No.
You're right. Angle C. We haven't done it yet. We're going to solve for angle, but we can, right?
Yeah.
Because we're given big B, little b, and little c, well, signs would say we're going to solve for big C. Okay? So what's going to happen is if you're visual, I'm going to draw this to help you. Sorry, this is not what I want. There we go. Here's what we're given. We're given B is 38. We're given the 21. And 25. Okay. Trying to draw this out to help you. See the light blue highlighted? That's one triangle that you can form. Okay? And then this blue here is the other triangle that can be formed. Is that making sense?
Yeah.
So, basically you can split your paper in half, and we're gonna have two triangles to solve. Triangle one. Let's see which one we get first when we go to solve for big C. So you would have set up sine of big C over 25 equals sine of 38 over 21. Okay, we're still going to cross multiply and everything. So 21 sine of C equals 25 sine of 38. And divide.
I'm trying to figure out where the whole sine C over 25 came from. Are you just plugging stuff into the formula?
Yeah, just into the law of sines.
Yeah, that's what I thought.
Okay, when I divide by 21 then. Now, if I have a number, but I want the angle, what function do we use? Yeah. So C is going to be the inverse sine of this number here. Now think about it, because I'm seeing some weird stares. Hold on. Before break, if I would have given you this, wouldn't you have done theta is sine inverse of 3/4? You're okay with that, right?
Yeah.
The number is just a little more complicated now, but it's the same thing, right?
Yeah.
We okay?
Yeah.
I know that's the issue because there's more numbers, but you know what's going on. All right, so on your calculator, you can put this all in one swoop. So do sine inverse. I forget the numbers already. Can you tell me? I think. So if you type it like that, it'll work. Oh no. It didn't get the right. All right, so we got the acute version of C first, didn't we?
Mm-hmm.
So triangle one is actually the dark blue triangle. So C is, what is that number? 40?
47.133.
Okay. Are we good so far? Okay, and then here's where I like to work on simultaneously. You remember that whole thing we went through a little bit ago? And I said, We just found the green, right? The 47. How do we get the purple? So triangle 2.
Yes. You know. I'm sorry. I'm sorry. I'm sorry.
So that's our acute
Sorry.
version of C. Our obtuse version
Yeah, I understand.
taking 180 minus
I'm not.
the 47. And ideally we would store all these numbers, blah, 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 but I'm okay with you using the rounded from here. Unless you're super particular, you can store them, but I'm not worried about that. What'd you get? You got it, Brooke? Any questions?
Bless you.
Oh, wait.
It's 132.887.
Boy. Oh, God.
So I'm gonna color code here. Triangle 2 is the little guy there, and then first triangle is the outer one. Okay. Questions so far? And then the one mistake I see, these three numbers never change, do they? They're the same for each triangle. Okay? The only things that are changing is from here on, you'll have 2 different C's, 2 different A's, and then 2 different little A's. We good?
Yeah.
So big A is what you should find next, right? Because you have big B and big C. So go ahead and take 38 plus the 47 and subtract that from 180. Oh, great. And then do the same over here. Sydney, what's that first one? Oh, is that what you're giving us there?
I rounded it.
Yeah.
All right, and then finally, we just need to find little a. So set up 2 law of signs over here. I didn't know it either. I thought I had mine done too. Do you have first little library?
Yeah. 33.97.
Okay. Try the other one.
5.414.
All right, do we have agreement?
Yeah.
So this is pretty simple, right? Now, you don't have to memorize the charts, but you will need to memorize the log line. That's not it. Okay. All right, couple more. By the way, this packet has both sections in it, so we're not gonna work through the other section tomorrow. All right, this one says determine the value of C that will produce the given number of triangles.
Whatever, I'll do it here. I'll just do it.
Okay, what I will say is we need to relabel again. We're back to the chart for a second. Big C will become big A. Little c will become little a. And D can stay D.
So you always just need a big A.
Big A.
On the other side.
And this is kind of cool because you work backwards. So see how A is 53, so it's less than 90? So we're in case 1 again. And we need to relate, we need to compute B sine of A, right? So for 0 triangles, A would need to be less than that number. Okay? So if we compute that, so that's 12 sine of 53. So find that rounded to 3 places for me. Let me know what you get. Good. So for the no solution case, right, we would need, A would need to be less than that. So first part, A needs to be less than 9.584. So that part. The middle one, it needs to be equal to. There's one little exception in that middle. You see? We haven't really talked about this box. But another scenario could be A would be greater than or equal to, what's B? 12. So you have two cases. Either it exactly equals that, or A is greater than or equal to 12.
How did you figure out, like, how we're is less than, like, that and stuff? What is that? Like, how you go, A is less than stuff, like, how do we know A is less than something?
So see this right here?
Yeah.
A is less than B sine of A means no solution.
Oh.
Equal to means 1, or
greater than or equal to, so we just need to know based off of.
The chart, which you don't need to memorize the chart.
So, but how do we know which ones we use and which ones we don't? Oh, between 0, 1, and 2. It's
Yeah.
just it.
All right, and then for the 2 triangle case, we would strictly just be greater than 9.5.
He's meditating. Maybe that's not what it is.
All right, I don't know if we can do this problem in 5 minutes, so I think we'll save it. But you know who this is, right? Please tell me.
It's,
Joey from Full House.
Yeah.
Joey.
So I think from Full House, Ranger Joe, Joey Glass. We can talk about why they're looking at a fire tomorrow, but, the homework. I think I'm gonna collect both sections at once. So earliest would be Tuesday, but I'll let you know for sure tomorrow.
Alright.
Okay?
Oh, I thought you said we're gonna make a pretty wild fire. I thought we were about to do it.
Oh, no. It'll give us something to look forward to. Please do not line up. Can you put the calculator down and make sure that
I'm not.